All right, we could probably get started. Let folks will hop on as they hop on. All right, so give me 1 second here to just pull up. Not a whole lot on the agenda today, and also Parth hasn't joined yet. So yeah, let's get started. Give me 1 second. Sorry, that's right on my agenda. Okay, so we can get started. Just as a reminder, this meeting is being recorded and at some point will be uploaded to YouTube. And also this meeting falls under the Open SSF Code of Conduct. All right. So right now, let me share the notes here and you can put in agenda. Put in your attendance. Give me 1 second. So, through the document and chat, feel free to put your attendance in there. So not a whole lot on the agenda today. Let me see if I can get Parth to join in a little bit. He was going to talk a little bit about the runtime visibility piece in Tetragon. That does some of the work that we've been doing on that front. So as a reminder, the idea there was to have all the core components of Fresca, including stuff like the pipeline framework and the policy, as well as the identity piece, and then followed by the runtime visibility piece. Those are sort of the three core components that sort of make up the secure software factory, or sorry, to implement the secure software factory. And so one of the big pieces that has been missing has been that piece. We're still working on getting SPIFFE Spire, the Spire work integrated with Tecton chains, or Tecton and Tecton chains, which will allow us to also hit the other stuff. So when Parth gets on, he can talk to some of that and show some of that off. But besides that, there's a couple of other sort of smaller things wanted to chat through. I know one is to maybe get an update from you, Brendan, just generally about the registry and some of the other cert manager stuff you've done.
And can you hear me now?
Yes, I can hear you now. Sorry.
Okay. No, it's a Zoom thing. I got to downgrade this thing at some point. Sorry about that. So yeah, got a couple things I've been working on. Yeah, it's been various pieces there. I'll throw up a quick example here just to show a little bit of what's been going on. All text. But the big change, if you export now this registry, I'm spinning up a registry instance inside of the container environment, inside of the Minikube environment. And so now when I run this whole pipeline, I haven't tested this, so we'll see if this actually worked today. This is kind of like a moment of truth here. I check my logs. Good, they ran. That's why I did this early. And now I can do the normal image exports and stuff like that we do. I'm just kind of picking from the READMEs. If you ever go through the README of the examples, all these commands are listed in there. And so I can kick those off to say export those, the task run the image URL. But I'm going to add one more that if you look at the README, it's commented out, same as the export command above when I did the registry export. But you can run these as well. All this stuff is turning off the ttl.sh server that we normally use. So if I echo right now, if this worked, yeah, this is now talking to a registry inside of my local environment. So separately from this, I've actually spun up like a make registry proxy. I think that's the make command I have for that. I don't want to switch tabs because I got too many other things on the screen here. But given that, I've got that proxy running. The port is accessible on the 127.0.0.1, just with the Minikube proxy running. And so I can see my container images all running locally. I can verify them all running locally. So we can see all those commands, all the different output there that we're expecting. So all this verifies that we're checking all these images and it's all on a registry that's running locally on this machine. And so if I was to dig into that a little bit, pull this up, I'll show it on the big screen here. I think I need to do this. So I've got the setup certs, which is spinning up cert manager. And so this one creates cert manager along with a whole bunch of bundles. And as Michael has found out, some of these bundles get a little complicated when you have large files. And so we need to change how we're shipping this into the containers. Because what I'm packaging together is the certificate bundle from the host, or if you don't have one of those, I'll pull it out of Alpine. And then I also have to generate the cert bundle for Java because we have at least one pipeline doing some Java stuff and it tracks certificates a little differently. Those get pushed into all the different containers using a couple of configs that we create. And so we make a config map for the Java certs and the CA certs. And we actually throw that in a loop in the registry namespace, the default namespace, the Tecton namespaces, as we patched all the different task runs and whatnot to mount these certificates into all the containers we're running. And so the jobs we're running, everything trust this local registry. So within the job, it's trying to talk to registry.registry, and we're injecting the CA so that we trust those registry servers in there. So I know I'm a little bit rambly here. This wasn't super prepared, but any questions so far, throw them out at me. And I'll pull up the chat so that I can see if anybody's throwing things at me. You're all looking very quiet this morning, which probably good if you're looking at this kind of code because certificates are never fun to look at. But this gets rid of at least all the OpenSSL commands. I think those were bugging some people because those get very specific to which install of OpenSSL you've been running. So it gets rid of all of that.
Cool.
So that's what we got. Did Parse show up?
No, but I might be able to show off his piece.
Okay. I'm trying to figure out if there's anything else important in here that we want to hit on before I jump off. I mean, the registry setup itself is pretty straightforward. It's spin up a registry server. I've got a couple configs in there, and then we just make sure the registry itself is fully deployed before we continue other stuff. I was getting this out of the Minikube instance of the registry because I want this to run across all the different, whether you've deployed your Kubernetes with Minikube or you're running into something like a Google or somewhere else in the cloud. You're not depending on which registry, which instance of Kubernetes you're running to be able to use our registry here.
Cool.
And like I said, there's a make for the registry proxy. I've got this kicked off in another window, so I don't have to leave it up and running, but it just spins up the registry on port 5000 and whatever machine you're on by default. So you can run all those crane commands against 127.0.0.1, and it just goes through the kubectl port forward to get to that. So I was getting one less dependency out of the tree. I'm trying to get stuff that we're talking to outside of our environment, get a bunch of this internal so that we don't have a lot of these external dependencies. So that's where this is going. So with that, I will wrap it on up, turn it back over, let Remy keep throwing his tomatoes at me. And let you take it away, Michael.
Sure. Yeah, I can show off what Parth has been working on, because I've been working on a good deal of it with him, but he knows it better than I do. And too bad the demo doesn't really, it's not a whole lot of nice things to show off because it correctly stops the demo from running, which means that, okay, well, not a whole lot to show off there. Okay, so one of the things, just as a reminder, that we've been working on is, we need to have a runtime visualization, not runtime visualization, runtime visibility piece into in Fresca in order to get it compliant with sort of the CNCF secure software factory, right? So as a reminder, like, you have the pipeline, policy and that sort of stuff. That's sort of managing what is allowed to run from a pipeline perspective, what tasks and so on, like, am I allowed to build Go versus Python, those sorts of things. So that needs to be there. There also needs to be sort of zero trust identity piece, like in this case, like short-lived workload identities via Spiffy Spire. That helps us then validate that a given workload was spun up correctly. And then finally, we need visibility that if somebody does somehow get into the container, are they doing all the right, do we know that? Can we detect anomalous behavior and those sorts of things? So, there's lots of different tools out there. There is, Aqua Security Tracy, there's Falco, there's a bunch of different things out there. And one of the ones we've been testing out has been Tetragon coming out of Cillian. And so what Tetragon is for is Tetragon allows us to, let me see here. So Tetragon, what this allows us to do is, I just show you some of the code I had up before. So this is the setup. Doesn't really matter a whole lot, but the basic idea is it's similar to sort of Tracy or Falco or some of these other ones that use eBPF as along with other sorts of kernel and process hooks to sort of validate, like, what is a process actually doing and capturing anomalous or weird behavior. So if you notice, hey, this this application all of a sudden starts poking around in my .ssh folder, okay, I want to know that. If something tries to use sort of common things like, I don't know, looking at the Etsy shadow file or whatever, right? Like I want to block that from happening. Now that's very much more like, hey, you're running a process on a server or something like that, but still at the container level, you want to be able to do some of these things, because if you start to notice, hey, a process starts injecting stuff into bits of memory and starts trying to execute that usually sort of some of those types of behavior can be used to, some of those behaviors are indicative of stuff like, hey, malware has attached itself to a process and is now trying to inject malicious code into memory and run it. And so I have this running. It's not actually doing anything super fancy. In fact, actually, it's not really. If I do pipeline, I just list the pipeline run here. So this pipeline currently running, but if I actually look at, I already ran it, but if I do, I get the pods, you'll see this is image pulled back off, and we're still trying to figure out how to make this a little bit nicer. But one of the things that this does is this particular container has a bad binary in it, and we have Tetragon set up to sort of stop that bad binary from running. But also in addition to that, it detects that the bad binary is in the image that's getting pulled down. So it doesn't let it run, it doesn't even let it get pulled down. So we're trying to figure out a way to sort of structure the demo to, make it a little bit nicer, where we actually get to pull down the malicious binary in the image and then run it and then show it that, like, hey, it's starting to do anomalous behavior. Let's shut down that build. There's a couple other things that we need to kind of figure out how to do. One of which is like, if we do, like if Tetragon does discover something, then we want to make sure that, and in fact, actually, let me open up some of the Tetragon config stuff. Let me move this out of the way. One of the things that we want to be able to do, right, is we want to be able to show like this thing actually, killing something that as it's about to run. But anyway.
So Michael, this sounds pretty similar to what I had submitted the proposal at CNCF. Let me post the link, right? And I think I had discussed that there. So I just post the link. And yeah, so this is something I talked to Liz Rice at KubeCon, right? And she basically, and I shared that I think earlier in the meeting that the Tetragon essentially is very useful. So actually, I'd like to share something. So I was doing this using the Tetragon to build this, bring some monitoring into the pipeline. So let me actually share. I couldn't do the demo last time. I think I had some issue with the network and stuff. So let me. So it aligns very well with what we are sharing here. So this is essentially a test app. Let me post this also in here. Where's the chat? Yeah. So again, this is a simple Tekton pipeline which builds the application using Kaneko build. It has two-step: clone the repository and run the Kaneko build, right? And in the Docker file, you can see it's a simple Docker file. It says this is the base image, do upgrade, install something wget, and this is something I added to show the value, right? So here we are downloading some dependency through curl and wget, which are typically missed because in Docker file people can basically bring anything. And when I ran this with the pipeline, I can show it, have it ready, but when I run this pipeline, it produces the logs, right? And the log, this is a Tetragon log, and it basically tells exactly the pod which actually was running and the processes that got spawned inside that particular pod, right? And what actions they were doing. For instance, if you see, you have one task which is git clone, which you just get it from the Tekton catalog, right? And we assume that it is doing the job that it is cloning the repository. But if it look closely, it is actually doing more. It is spawning a lot of process. It is doing deleting a lot of stuff, and there can be malicious actions here, right? So if some malicious user puts some git clone task, which is intruding with the original artifact, that was the primary motivation I started looking into this introspection, right? So this essentially brings the visibility, like when we run the pipeline, what actions are getting executed, what network connections are getting pulled on. So it shows this is the task, clone repo, what the processes are getting spawned inside it. Similarly, from where it is actually cloning the repository, right? So egress that are going from that particular pod. So for every actions like build and push, where it is pulling the image from, like Kaneko build and push image, it is pulling image from this particular registry. And if I have in an organization, because in my organization at IBM, basically we have policies that we want to pull all the images from our own registry, right? Our own artifact registry. So the address should be 9.xyz, which is our intranet. And here, if we see something going out of that, we can basically flag those actions. And it basically gives you all the insights, like what these are the pods that are running, what network actions, what process actions, what messages, and this is the push, that where it is actually pushing the registry or pushing the built image. And yeah, this is essentially giving the visibility into exactly what is actually going on, because right now our build is essentially a black box. We don't have a lot of visibility into what it is doing. The other question that I get asked is how it is different than chains, right? So chains is a Tecton chains. It is doing the introspection for the task level, right? It is not going inside the task and inside the pod. It says this particular Tecton task ran, and this is the attestations for that, right? It doesn't tell you if you can trust that particular task execution or not. For instance, it says this image was built by this particular Kaneko task. Now with this additional metadata, we can say that these actions ran into while building this task. And the proposal that I had submitted was essentially to bring that visibility. Like when we run it, create these records where it shows that these build steps were run. And this can be even extended to the Tecton, like not only the build step, but git clone task, git clone actions was run, and it actually had this egress connections. It had this file created, these resources created. And if it look into this log, the logs essentially will be fed, will be processed. So the next action for me was essentially to process these logs and create those attestation records, and maybe put it in the in-toto layout so we can basically parse it and use it with the existing framework.
Cool. Yeah. No. Yeah. That's awesome. Yeah, I think would love to get you sort of synced up with also Parth, because I know he was running into, I know the Tetragon documentation is lacking, to say the least. Yeah, and so a lot of the stuff in there is a little confusing as to whether or not it is like and or like when you have multiple policies, are they anded or is it, you know, ored? And some of that can get a little confusing, and I know that we want to kind of go through some of that. And then also, as far as the attestation piece, yeah, that's something else that we've been poking around with. And I know that Cole from Testify Sec has been poking around with using Witness to wrap something like Tetragon, to then take what's coming out of Tetragon and then sign off an attestation on it. That might be something that we might want to look at as well. And then separately, we want to make sure that we have some way of actually like taking the output there. And like the attestations is the first step, but the second step is also to say, like, if you see really anomalous behavior, right, you should be probably killing the build. And how do we do that is not exactly clear to me. I mean, it would be very easy to just say, okay, we'll have this somehow call out to the Tecton API and tell it to stop the build or something like that. I'm sure we could probably do something like that. But like right now, you know, if we go in and stop a container from running, Tecton really has no idea what to do about that in a lot of cases. Like, for example, the image pulled back off, it's like, there's a timeout that if I can't pull the image after 60 minutes, I'll kill the build. But really, it should detect like something like Tetragon should be say, hey, I am stopping this from running. So I'm going to now send a, you know, figure out some way to correlate it to the build and then, you know, kill the pipeline or something like that. And once again, that I think is further on. I would much rather, based on what we've seen thus far, maybe do something like, at least for now, you observe it and then you write an attestation. So like, you know, hey, I detected anomalous behavior, or I detected no anomalous behavior, and sign an attestation for that. Cool. Any questions or comments about any of the Tetragon stuff? Also, a minor update on something I'm working on, just because now my dev environment is mostly NixOS. I'm going to be making a PR to make the environment a bit more the make scripts and whatnot to be a bit more platform or distro agnostic, I should say, because right now it's set up to either run on Mac or whatever. But doing stuff like, as opposed to just calling bin bash, calling user bin env bash, that sort of thing, which means that, hey, if you don't have bash installed under bin, which a lot of folks don't, not just Nix, to be clear, not just Nix, but a lot of things don't have it installed under bin. Some have it under user bin, user local bin, whatever. It'll be able to go in and detect, whatever the environment bash is, and then use that one. And there's some other like little things to make it not just assume via unless the paths were generated by Fresca itself, it won't make any assumptions on the paths. So there's a couple of things there, and that kind of leads into the next thing, which is like, hey, as we oh yes, eBPF does not work on Minikube on Mac because Mac OS itself does not support eBPF. So which leads to two problems. One problem is that, yeah, even I'm running an x86 Mac or AMD 64 Mac, whatever, that will not work with, like if I just run this locally via Minikube. But what I can do is I can easily spin up a VM and run it. The problem is those who are burdened with M1 Macs have a bigger problem where they M1 Macs have even though M1 Macs can spin up VMs that are running Linux, a lot of support for Linux on M1 is still evolving. Not everything works. Brad, who's not on right now, I know he's talked a lot about like it works. It's not the greatest performance, but it does work. Actually, I'm not sure.
The problem isn't so much that Minikube is in a VM, it's that it's doing a architecture specific VM usually for performance. And so it's going to run ARM64 instead of AMD 64 code.
But shouldn't, if it does the ARM64, doesn't ARM64 still support eBPF?
It apparently doesn't. I haven't dug into it.
Yeah, that's anyway, that sort of leads into actually what I was going to talk about next. And yeah, so a lot of this could just be that like some of these things are just, most folks are using 60, just AMD 64, x86 64, whatever you want to call it. And between ARM and M1, however, over time, we do want to obviously support some of these things, especially given that some of the folks who have been interested in Fresca, over, let's say, using like, hey, why would I not just use a GitHub action? Well, some of the folks were like, hey, I need ARM64 because I'm building for, I'm using some of these devices or edge devices or whatever. And yeah, there's all sorts of stuff that's being kind of brought up there. So some of these things might not be, might require some additional stuff on that end. And so in that case, we might need to sort of work with folks as well. Yeah. Stock desktop. Interesting. Eric, yeah. I'm sure we'll have to kind of poke around a little bit and see how that all works. And so, Eric, is that on M1?
If I can get my camera working, sorry. Yeah, gosh, I've got both, and I'm pretty sure I've done it on my M1 as well.
Oh,
I know we did a talk where we showed Falco running on M1, so yeah, it should work.
Okay, cool.
I wonder if the problem is less that eBPF doesn't work and more that there might be images that are only built for a single platform.
Yeah, that
and
sounds
calls that are
plausible.
looking for the x86 specific calls as well.
Yeah, and I mean, on that end, that's the sort of thing that I think we're trying to also build as an added abstraction layer for Fresca, is, pretty much make it so that, if you're on a particular environment, okay, this is the set of rules you get. Obviously, there's a maintenance headache if you need to support multiple different, let's say OSs and lots of other things, and architectures or whatever. But I do wonder, yeah, if it's just something like that, if we can detect that it's, hey, this is ARM64, okay, you do this, and try and make it as cohesive as possible would be, I think, valuable. But yeah, that's interesting. Okay. Wait. Um, Cool. So on that end, I'm curious. So do folks? So this brings me into the next thing, which is just we want to, as much as is possible, have a relatively cohesive development environment so that we don't end up inadvertently stepping on each other's toes, where like somebody goes and says, "Hey, this worked on the M1," and it's like, "Oh, it doesn't work on x86 anymore." Hey, this, and we're building out tests obviously for some of this, but at the same time, given that a lot of folks are moving more and more over to M1 for development, we're in a bit of a conundrum here of how can we make sure that folks, regardless of their device, can do some interesting dev work while still making sure that their dev work looks similar to what this thing is supposed to look like in production, right? Because if the idea here is, everything except runtime visibility works on the M1, so we're just not going to install that on the Mac because we're not using Macs as production, it'd probably work for a while, but if you need to test something, or if you introduce something at the M1 level and then you deploy it out and you're like, oh, it's breaking because it's breaking a tetragon rule or whatever, or a runtime visibility rule. I know these are some of the things that we're trying to figure out, and we're looking at brainstorming, whether it is asking OpenSSF for, hey, can you give us a couple of VMs or give us a GKE, cluster or whatever, just some sort of, like a couple of dev Kubernetes clusters that run on x86, so that, hey, I can run my, write my code locally, deploy it actually out to a dev environment, test it out. Hey, it works. Cool, we'll tear it down and move on or whatever. Those are some of the things that, chatting through, especially given that I know Brad's not here, but as I mentioned, Brad has run a couple of the VMs trying to emulate, either emulate x86 or just run Linux via M1, and it's mixed results currently. So wanted to throw it out there if anybody had any thoughts or ideas.
Well, tangentially, I've dealt with this issue with another company's product. I won't name a name, where the expectation was, well, developers aren't shipping to ARM, so we're not going to worry about the user experience on ARM, and they can just run dash platform or whatever to make it run under the QMU, and the performance is so abysmal when you do that it becomes a UX nightmare.
Yeah, and so that's the thing here is like, we don't want to end up in that situation, right?
Right.
We want to, as much as we can, and there might be trade-offs, and we might have to say, hey, look, for now, this is what will run on your M1, but if you are doing dev work in these areas, please be aware, because just some of the stuff that we're using, just by the nature of some of that, is just not going to work. Potentially wait for Mac to maybe up their virtualization game or whatever. I'm ambivalent on how we necessarily do it. I personally, like, one of the things I do, but this is just, I can do this because I have this, is I have a little home lab that I have teleport set up on, so I have a zero trust thing, and I can just, yeah. Well, yeah, two Macs.
Two Macs
Yeah,
is how I end up doing it right now.
yeah. And so with that said, like, I'm just curious if other folks have other ideas. If folks are interested, we can maybe push on OpenSSF a little bit to throw us a little bit of compute that we can spin up stuff on, so that those who are who need it can kind of use that when they like, once again, like, hey, if Remy, who I know has the M1, if he's working on the tetragon related stuff, okay, well, you need to use some of the external compute because that's the only way it's going to work right now. Or, hey, I'm just working on some of the normal process stuff and I'll test it in dev once I'm ready. I'm sure we could probably figure out something there. Remy, do you have any thoughts? Because I know you're the one who's most adamant with the M1.
Yeah, I mean, I like the idea, but mostly for me, like the remark I had with the tetragon stuff was that if I run it on my machine, it's just going to keep crashing in the background. So that's kind of useless. So if we could just have like a check or a flag or like something which auto detects M1, and then I can keep working on the rest. And when I need the tetragon, if I could do like you said, like OSSF, Google, Microsoft, whoever gave us some compute, I can use a remote compute to work on it.
Oh, go ahead, Brendan.
I was going to say, speaking of all of these multi-platform images that we probably don't have for a lot of these tools, it might be good for us to start working on multi-platform images with Fresca itself, because I think everything we build is single platform. Complete aside.
Yes.
So.
Oh, yep. That's probably worthwhile. I know that a couple of us have some conversations with ARM next week. So we're going to probably try and chat about some of that. Actually, some of the stuff that we're going to be chatting with. So if folks are interested, yesterday at the SIG-Store meeting, Parsec, not the gaming one, the CNCF project, Parsec, which does stuff like ensuring that secrets are coming out of TPMs or HSMs and help you sort of essentially acts as an abstraction layer into containers, and also just acts as a general abstraction layer, because I don't know if, as somebody who has had to use like PKCS or PKSC, whatever it is, PKCS 11 before, where it's like essentially the only thing you get is like a function signature, and like you just need to make random calls and hope for the best. Parsec is trying to abstract that out and essentially just act as an API layer where you can essentially just ask Parsec, hey, Parsec, can you generate me this hardware backed key, or can you unlock this key on my behalf, or whatever, and it can do stuff there. The auth model still seems a little not 100% clear to me, but generally it does seem like they're doing a lot of the right stuff. Most of the folks who work on Parsec right now are ARM engineers, engineers who literally work at ARM, not the architecture of the company. And so they seem to be interested in sort of also hearing some of our use cases and whatnot. So I was gonna, they have, their meetings are 11:30 a.m. on Tuesdays, Eastern time. They're mostly UK focused. Cool. And so anyway, just wanted to kind of throw that out there as well, because I know one of the things that we want to be able to do with Fresca eventually is we would love to be able to say Fresca builds happened on particular hardware, and we can prove it because the keys are backed by the TPMs on these specific devices, and so they couldn't have been faked, and those sorts of things. And then some other stuff that is being sort of discussed, that is also going to be discussed, is some folks have talked about, could we use Fresca to run builds inside of trusted execution environments, secure enclaves, that kind of thing. And looking at stuff like confidential containers, that project, and working with them to start to, they're not 100% there yet, but there could be some cool stuff there, right? Where it would be really neat to say, hey, like, I know some of the folks that we've been talking to they're potentially concerned. They're like, hey, we don't want anybody to actually know what code is actually being built. Because the code itself is the intellectual property. So if the code leaks, that's like actually, that's in some cases, just as dangerous as if the code was compromised. And so there's some discussion about, could we do stuff on that end with Fresca and so on. And once again, these are things that are probably 3+ months out, but just wanted to kind of highlight that as some interesting things that folks are talking about and interested in using Fresca for. So another thing on the dev environment, wanted to get folks' thoughts on is the make files are starting to get a little unwieldy, or sorry, not the make files, the make files plus shell scripts are starting to get a little unwieldy, just because I think, as Remy brought up, like now we have to sort of flag, like, if I detect your M1, then do this other thing. And if you start to add a lot of that, just in purely shell scripts and make files, it's going to be, I think, really difficult to maintain, because like, a lot of things even right now, we have like a lot of if statements, like if your Mac, do this, if your Linux, do this, and we're doing certain checks on Linux that we're not doing on Mac, and we're doing certain checks on Mac that we're not doing on Linux. And I don't know what the option is here, but we probably should think about, from a dev perspective, what sorts of things could we have, and does it make sense to actually split it out even further, where we just say, like, here is, as an example, here is the Nix build script, like you can run Nix shell and it gets you your dev environment, or here is the the M1 setup, and do stuff like that. Or I don't know if there's also nowadays, if there's good configuration management stuff, like running, I don't know, like Ansible locally. I'm ambivalent. I'm just trying to figure out something here, just because we are noticing, like, with a lot of the stuff right now, is it feels very brittle. Like it takes like one change and all of a sudden a lot of other pieces begin to break. And just curious if there's other tools out there that folks are aware of that can maybe help manage this. And some of it could just be, we deploy a lot of the tools into a container, and we have a container image that's all of your tools, which some people might like that, some people might not, but just anyway, wanted to throw that out there to brainstorm.
Yeah, at least throwing all the tools into a container was something I was looking at earlier with different use cases, talking to the registry, installing all the different cosign tools and Crane and whatnot. It's an option. It just adds a little bit more complication to how you run those, because now you have to exec into a container to kick these things off.
Yep. How about Flatpak? Anyone?
I'm not stepping on that man. No takers. Okay. What's the? Getting into Snap versus Flatpak.
Yeah, no, there's one, I think there is a Nix bundler, which I believe, it uses, so it does not use Flatpak, it uses ARCs.
I was about to say, there's gonna be a Nix comment coming in here in a minute. It couldn't be far behind.
but there is this sort of thing, which allows you to sort of, so anyway, I'm not gonna go down that rabbit hole, but there's some interesting work around like literally packaging up all the dependencies all in a single sort of bundle. Similar to just sort of saying, hey, I statically compiled the thing, but for stuff that you can't statically compile. But anyway, yeah, I just think we need to start kind of looking through some of this, because I know with a lot of the stuff that has been happening lately, we've started to get some intermittent behavior, some, you know, different things. And I just want to start to sort of think of how do we make this, I guess, just a little bit nicer to develop on and nicer to use. But yeah, any other thoughts, comments? Otherwise, can give folks back a little bit of time. Interesting. That thing you just sent, Jack, looks really cool. Anyway, cool. Yeah, like I'm more or less just wondering, as we kind of go through some of this, like how do we package up Fresco tools along with Fresco itself, right? Because we're doing a lot of stuff where we're installing a lot of the other tools that are required, but at a certain point, and you know, we might need to, at some level, package that up, you know, with the appropriate sort of attributions and licenses, saying, hey, we're packaging this up as a dev bundle for these things. Because of course, the problem that we have is we have the other supply chain security problem or supply chain problem, which is just not that, like, it's not just the libraries that's the problem. It's now we have a million different tools that need to be used in order to actually build this thing out. Anything else? That's a lot of neat stuff though, Jack. Cool. Anyway, I'll give folks back 8 minutes and see you all in 2 weeks. Later.
Bye-bye.